Okay, so at the end of the last video tutorial, what we were doing was leaving the batch script processor to export the high poly sections of the model. So it was going to take a fair amount of time just because it was a very large model, 9 million polygons, and it needed to go through and cut it up into little sections and then export it. We'd already finished the low poly sections, so here we are in our project folder. We'd already finished all of the untextured sections here, and we were just leaving it to run through the high poly sections. And you can tell that they're the high poly sections because they're pretty big, about 200 megs each. If we go into, as I say, this is kind of useful little free viewer, Mesh Lab. If you want to get that, it's not completely essential for this, but if you just search for Mesh Lab, then you can download it from the website for free, and it runs on a bunch of different platforms. So it should run on Linux and iOS. Sorry, not iOS. Actually, there is a version for iOS, although it might not be useful for you. It runs on Windows, Mac, a bunch of different things. So you can. This just started downloading already, and install that, and you get this little viewer. I'm just using it now, so we can take this high poly. Let's just have a look at one of the high poly sections. I'll just pull it in, and it will load it up. So it's loading the face detail. It's fairly big, 160 meg. And there it is. So this is how many faces? So about 900,000 polys for this. So it's very high detail. You can see them there. So we have a folder of the low poly sections and a folder of the high poly sections. Both of them are untextured, and what we need to do now is go through and run a script in PhotoScan which is going to apply the texture, project the texture from the cameras back onto the models. That's really important for the high poly sections because that texture is going to form the basis of what we then project onto the low poly models. But we need to do it for the low poly models as well, just to tell xNormal how the image file gets wrapped around the model. We'll look at that in a little bit more detail when we start looking at the maps that it produces. But for the moment, what we're doing is taking a high poly mesh and a low poly mesh and projecting the detail from the high poly mesh onto the low poly mesh so that it perceptually looks as detailed. The geometry isn't as detailed, but when you project a bump map and a normal map onto the low poly, it looks like it's got all of that detail on it. So that's what we're going to be producing. Here's another demonstration image. I just searched for normal mapping on Google Image Search to get some sort of good illustrative images. So what we're effectively doing is this is our low poly mesh. We have a high poly mesh that's got a lot of detail on, and then we're running it through xNormal to produce this map that will be applied over the top and make it look like the original geometry. Okay, so we're going to be doing that in PhotoScan. And as I say, this is actually the bit where you do need to have PhotoScan Pro to run this script. If you don't have this script, then I'll go through now and show you what you have to do manually. It makes it take a little bit longer. What you're effectively doing is loading in every single section, every single part that we've made, the low polys and the high polys, and individually going through selecting texture to generate the texture for it, and then exporting it out as a textured file. So I'll do that now. This is just, as I say, if you don't have the Pro version of PhotoScan, then this is how you would do it. So I'm going to go to Import Mesh, and I'm just going to select my project folder, and I'll start off with the high just to give you an indication of how long it takes on the high poly sections, and I'll just start off with high box 001, and I'm also going to cut and paste the name of that file so I don't have to type it in when I'm exporting. So it's going to replace this mesh that we've reproduced with our little segment of the mesh. So it's going to be a section of this mesh that we've cut out previously. Okay, so there it is, it's the first one, and if you remember when we were making our envelopes to cut the model up, we started here and we copied them across and then copied all of them down. So this is our first position. What we do now is we're going to project the information from the cameras onto this surface to get a better texture, to texture the model. And there's two things that are going on there. One thing is that it's the first thing that it actually does is figure out the best way to wrap a little square image over this this bit of geometry. So it's trying to figure out the best way to sort of shrink wrap or to fold a 2D image over the top of this, and that's called parametrization. And then once it's figured out the best way to map that image onto this, it projects the pixel information from these images onto the model and then puts it into the map. So we'll see that in a sec. So we've loaded up our section, and then we go to build texture, and we're going to build it at 4K. There's a few options about how you build your texture, which will control the way it takes images from different cameras, and also the way that it tries to wrap the UV map, which is the way that it's figuring out how to wrap that image over the model. These different settings will change the way that it tries to wrap that image over the model. Generic works pretty well, and then the blending mode is how it's reconciling different perspectives from different cameras to produce the final outcome. Mosaic is pretty much an averaging of all of the cameras that can see any of the parts of these models, and that works quite well. That's what the script uses. So if we say OK, it's parameterizing the model, trying to figure out the best way to map a 2D. So for example, a little square image, how best to map it over the top of this model. For the large, for the high poly segments, this takes a fair amount of time because there's a lot of sort of geometry to try and figure out how to wrap it around. For the low sections, it doesn't take quite so long. And again, this is only an illustration for if you don't have the Pro version of PhotoScan, because in fact the Pro version supports running a Python script, and I've written a Python script that automates this process, so you just sit back and let it do it. Alright, so here we have now the texture projected over the model, and this section is pretty far away from the camera, so it's not perfect. And you can see that there's some interesting artifacts here where a tree is in the way of one of the cameras. So if we were really careful with it, we could remove that camera perspective so that it didn't come up with that result. We didn't get the sort of silhouette of the tree over the top of it. But this is fairly far away from the rest of the model. It's right at the back of the model. So it's not a huge problem at the moment. Another thing to take note of is that this is a good way of seeing how the size of your sections will affect the overall final detail of your models. it's not a small, it's not particularly small or big, this section, but you can see that because we have a fixed size image that's projecting over the top, we'll have a look at it. If we view mesh UVs, you can see the image that it's applying over the top. So it's trying to sort of find the most economical way with the least white space of wrapping this little square image over the top of this model. And this is 4K resolution image. So that you can see that if this model was physically smaller, then the same number of pixels would be wrapped over a smaller size, and the overall resolution would be higher because it doesn't have to spread that number of pixels over such a big area. So if you want really high resolution reconstructions, or if you want really high resolution textures on your reconstructions, like you've got a lot of detail and you want to be able to zoom in and see it, then you can get that by making your sections smaller, and that means that the number of pixels applied to each section is more dense. Okay, so assuming that we don't have PhotoScan Pro and we're just using the normal version, we have loaded up our first section, exported section. We've applied the texture, we generated texture, and now what we want to do is just export this model. So if I go export model, oops. And this was the high. So what we're going to do is create another folder and just call this textured, because this model is textured now, and I'm going to paste the file name back into it and hit save. And we do want to export the textures, that's the important bit. So we've generated that texture. That's going to form the basis of the base image that gets projected onto the low poly as well. So these pixels are going to get projected onto the low poly version. We hit OK. It exports the image along with information about the mapping of the texture and the texture itself. And then if you were doing this process, you would just go in and, let's see, import the next one. So copy the next name, open this one. This is going to be next to it. I'm not sure why it's taking quite so long to load this relative to the other one. It's because it's much bigger. So the first section was only 80 megs. This one's about 220. So there's a few more polygons in. And that the reason why the sections aren't all this sort of equivalent number of polygons is because this little cut up bit was on the corner of the model. So the box was sort of extending out into this space without any information in it. So whereas this one, pretty much the whole box is covering some part of the model. So there's a lot more detail here. Okay, and then we'd continue on with that process of projecting the textures and then exporting them out as textured models. Since we're using the Pro version of this software, we don't need to do that. What we can do is go to Run Script. Actually, I'm just going to delete that textured folder that I just generated. We go to Run Script. We find the SiteViewer project folder, go to Assets, External Scripts, PhotoScan Pro, and it's just imaginatively called script.py. If we open that and run it, it's going to ask us for the untextured object folder. And we need to do it once for the low and once for the high untextured folder. It doesn't matter which one you do first. We've already seen how long it takes to go through that process on the high, so I guess I'll do it on the low just so it will be quite fast. And just select the folder and hit select. And now it's very, very quickly loaded in this section. It's going to texture it a lot faster than it was doing for the high sections. And then it's going to export those and run through all of the contents of the untextured folder and generate these ones. So what we can see is when the script first starts, it generates this folder called toTexturedObj, just because this is the second stage of processing these OBJs to differentiate it against the untextured. And in a minute, when it starts creating the textures, it's going to export, and we're going to see it build up here. Okay, so there it is, exported. And if we open up the texture file, we can see that it's generated this texture file of information. If we open this up now in MeshLab, just for illustration purposes, if I pull the OBJ in, if I pull it into MeshLab, MeshLab will see that there's a material file there which points to this box 1 texture, and it automatically loads the texture that's associated with it. Let's make it a little bit softer. So that's what we get. All right, so this is going to run through and process all of the untextured segments in the low folder. I'm going to cancel this actually now because I've gone ahead and already made them just to save time in the tutorial. And what you would do, so you run it once for the low folder and once for the high folder. So once it's finished doing this process, it will pop up and say export finished, and then you just run the script once more. And if you started with the low, select the high the second time. And if you started with the high, obviously select the low, and it will run through and process those. So I'm going to do a cooking program, time-saving process here, and here's one I made earlier. So I have the low and high sections. I'm just going to paste back in. And this is what it looks like when the export process is finished for all of them. So here's the textured low poly models, and here are the textured high poly models. Okay, so once that's done, we can discard our PhotoScan project. And now what we're going to do is actually produce the map. So we're going to use xNormal to project the detail and the bump maps and the texture from the high poly detailed geometry model onto the low model. So, okay, go back into our 3ds Max, go into your Maxscript editor. If that script that we were using before is still open, then you can just leave it. Otherwise, we know where to find it. It's just in your SiteViewer folder, Assets, External Scripts, 3ds Max, Export Tools, and then Export Tools. Okay, we'll hit Ctrl+E again to open up the little box. And we're not going to be using the segmenting tools anymore. Now we're moving on to using the xNormal batch tools. These settings are all sane, so they're pretty reasonable settings at the moment. So unless you have a good reason to change them, these are good settings to go for. So what this is the resolution of the final map, and it's probably best, unless you have a really good reason to change it, to produce the maps at a high resolution to begin with, because it's very, very easy to downsample them later on and to compress them and do all sorts of things, but it's not easy, obviously, to it's impossible to go from a low resolution image up to the high. We're going to be generating JPEG format maps. This is the level of anti-aliasing, and this is just something, an element of the processing. It's how the bucket size, how much information is processed in one go. We're going to produce the color maps, which is basically the visible texture on the model. The normal map, which is how, so if we look at this one, This is what a normal map looks like. It's basically telling the renderer which direction parts of that face are aiming, so that it can figure out how light will respond when it hits that surface. So that color means that the face is sort of facing in that direction. That color means that it's facing in that direction. So even though the geometry is completely flat, when it models light hitting the surface, the effect it produces is as if the surface is bumpy. And then we also apply a bump map, which does shift the pixels to make it look like it's bumpy. So we'll see that later on. One thing that might be an issue, the ray distance here is currently set to what I've found to be a good level. Let's have a look at MeshLab again. I will show you what it looks like when if you're starting to have problems with that value. I'll show you what that might look like. If you set that level to too high, then you're going to get, let's have a look. So here's my low poly. I've generated texture. Oops, I think that was the low. Okay, so if the value of that ray distance is too low, then you're going to get something that looks a little bit like this. And what it's doing is projecting from the surface of the low poly onto the high poly, and it projects only a certain distance. It casts a ray, basically like a ray of light, from the low poly surface onto the high poly surface, and it will only try and cast a certain distance because it wants to sort of be conservative on resources. So it doesn't want to have to search any further out than it needs to. So that ray distance that you set here, the max front ray distance, how far it will project in front of the surface and how far it will project into the back, because obviously the more detail could be either indented or sticking out. So if that value is too low, then you might get things, effects like this, where the ray doesn't actually get far enough to hit the high poly mesh, and you just get gaps, and also you get these sort of like very, very low resolution sort of sections. That's what it's going to look like if that's too low. It's probably not likely with that value that it's going to be too low. But now let's have a look at, where is it? Okay. Too low, and then this one is what it looks like if it's too high. I'll just pull that in again. Okay, so if that ray distance is too high, then what happens is when it's projecting the texture from this side, you get these weird artifacts like this in the corners, pretty much where there's one face that's sort of obliquely looking at another. And what's happening there is that it's casting the ray out, and rather than just getting to the point where it hits the high poly mesh, it goes all the way down onto the facing model and casts some of the texture from this side onto that side. So you get these sort of weird, they're very very easy to identify once you know what to look for, like very, very strange things where basically that line there is being projected onto that section there. So if you start getting those sort of artifacts in the corners of your model, then you know that your ray casting distance is too long. As I say though, this value is pretty sane, it's quite a good one. So there should be no reason, unless you start seeing weird effects, to change it. Okay, so pretty much what we've done is just opened up the xNormal batch section. We're in a completely empty project, which is probably best to be in. So you go to reset in case there's other content here, just so that there's no other models getting in the way. Then hit the bake button. What we're going to do is select it says, okay, select low poly textured OBJ path. So here's the one that we've just generated using that PhotoScan script, and hit OK. And now we select the high poly textured OBJ path. And finally, it wants us to select a target path. So this is where it's going to put the map script. So I'm just going to generate a new folder and call it maps in the in my project folder. It's selected, and we just hit OK. Now what it's going to do is load the low poly textured model and the high poly textured model, and then open up xNormal and perform the projection mapping. So one thing about this process, the color texture and the normal map texture don't need to have any user interaction, but the way that I've got it set up at the moment for the height map, because the height map texture is just a gradient between white and black, and gray means that it doesn't affect the height of the height of the surface at all. So if it's white, it pulls the surface out in the direction of the face of the surface. If it's black, it pushes it in a certain amount. But that amount is arbitrary. You set that in Unity 3D, and also it depends how you decide the coloring of your map. All of which means when it generates the height map, it's best to have a little bit of user interaction. We'll see it in a minute. It's going to pop up a little box that allows us to sort of tweak the values of the highest and lowest points. So you want it to be to have fair amount of black, fair amount of white, with nice grays in between. I'm just going to show you what it looks like when it's wrong. So obviously this is no detail at all of that is being pulled out, and if it's set to high, then there's no detail. So we want this sort of sweet spot, which it pretty much generates by itself. Most of the time when you're using this, you can happily just let it generate these values and then close it, and then it will use those values that it's generated. This does mean that you need to wait for every section for xNormal to open, for it to generate the height map, the texture map and the normal map before you get that point of interaction to generate the height map. What you can do, if you want to make everything go a little bit quicker, is in the export tools only select the color map and the normal map first, and that will run through without any user interaction at all. And then go back, reset the project. So here we go, you'd select just the color map and the normal map and leave the height map unselected. Run that through. You don't have to be there at all. It does it as a process without any user interaction. And then come back and deselect the color map and the normal map, select the height map, and then it will run through a lot faster. So you'll just be sitting there sort of waiting for it to load up, then applying that texture, and then it will generate that map for you, and then it will move on to the next one. So it'll be a little bit faster. Again, in the spirit of TV cooking programs, I've already run through this process. Let's have a look. Oops, not that one. So if we look at the progress at the moment, we've seen it's generated the maps for the first segment of our model. This is the texture map, which is just sort of the visual color that gets projected onto the material. This is the normal map, which is giving information about which direction parts of the face are aiming so that light will respond in different ways on it. And then the height map is actually pulling and pushing parts of that surface to recreate the detail of the original model. So it's recreating the geometry of the high poly model onto the low poly model using a very different technique, doing it in a very different place. So this is that was a height map popping up from the batch process that I've got in the background. I might just cancel it if I can. Cancel. Okay. So we can happily close this now that we've run through that process. We don't need any of this. These are the maps that we've just generated, but I've got one that I made earlier, a maps folder filled with all of the maps generated for those segments. So if I go back to the Creek folder, I'll just paste it in. Oops. Okay, so now our maps folder is filled with all of our 3 different textures for all of our models from the first part to the 12th part. Okay, so now we get into the exciting bit. I'll just close Unity 3D. This is now the point where we import our low poly models and our maps into Unity 3D. And from there we'll export them into a format that we can put online, and then you can point the SiteViewer to it and it will download and run happily. So open Unity 3D, and I've already got it set up here, but go to your SiteViewer folder and just hit select folder. It's importing all of these assets because it's the first time that I've opened this. So it shouldn't take too long to do this process. And in fact, I might be able to optimize the project folder a little bit. The skybox isn't being used at the moment, so that's something that I can take out. All right, and now we have, let me just resize it so it's actually a little bit easier to see what's going on. Okay, so here's our Unity project folder. And what we're going to want to do, we're actually in the right scene. Unity splits up projects into a project folder and then a number of scenes. And the scene that we want to go to is the main. It's actually set up at the moment, but if you go down to just in assets, just double click on main and it should load up. We can tell it's the main because it's got this world element here. Okay, so we have our low poly models that we've now got maps, a texture map, a normal map, and a bump map applied to. What we will do is go to the objects folder, and I will generate a new folder and just call it, well, what's this? Creek. And I will go into my maps folder, and I will select all of my maps, and I will copy them holding Control and pull them into the Creek folder. This is going to probably take a while to import because these images are pretty big. They're 4K each, and Unity has to go through and just figure out how it's going to deal with the different images and compress them in various ways. So it imports them with a default compression ratio and a default resolution. And then when you change that, it has to sort of reprocess that image, and that takes a certain amount of time. Okay, so here are images. You see that it's, even though the image is actually 4K, it's imported it as a 2K image compressed. But that's all right, we don't have to change that at the moment because the import script will do that for us. So we've pulled in the maps into that folder. Now go to your low folder, go to the textured OBJ, and just, let's search for .obj. Oops, OBJ. And select all of your boxes, all of your segment objects, and holding Control and copy those into this folder as well. All right. So now we have these boxes in here. You can see it's imported the model. Hasn't applied the textures to them, but that's okay. Our import script is going to do that. So in the hierarchy, generate a new empty game object, and then it doesn't really matter how many levels you do for this. I'm going to generate another one and call it Creek. And within Creek, I'm going to select every single box segment. Oops, I think I deselected that one. Okay, so all 12, and I'm going to pull them into that Creek object. So what it's done now is just taken all of these models and put them into our environment. And you can see that it's not really aligned properly. It's upside down for one thing, which isn't ideal. And this is pretty much the reason why we bring it into Unity to export, so we can set everything up. This is what it's going to look like in your final version. We can sort of preview what the setup is going to look like in the SiteViewer app, or desktop program or whatever. And we can add lights to it and all sorts of stuff if we want to. So we have our little sections here. What we can, before we do anything, we can go to TacticalSpace, import set object properties. This pops up this little box here, and we take the root node. This is the node which doesn't have actually any content in, it's just the node, the object that holds all the other ones. We pull that into object root. And now I'm just going to hit sort, and that's just going to sort them in order of name, so we can make sure there's no gaps. 1, 2, 3, da, da, da. So that's good. I'll leave this open, but I'll leave it over here, and I'll explain the other sections of it in a second. So what we're going to want to do now is move the model around and resize it to the point where yeah, that seems pretty good, to the point where it is the right size and scale relative to the camera position. So here's my first person controller, which is basically like a little person. If I turn on the mesh renderer, that is the height of a person in this. So we can, I'll just move this around a little bit more. Might take a while to get used to the interface controls for this, but that's fine. I'm just using the left, holding down the right mouse button to look around, the middle mouse button to move around, and then Alt. Which one is it actually? For well, that's pretty much it actually. Moving around and looking around. And the middle scroll to zoom in and out. Okay, so let's place this somewhere where you can see it. Here's the main camera view at the moment. You can see that the camera is sort of pointing in this direction, so we want to put our model over in that direction, so that when it all loads up, it will be facing in the right direction. So let's put it there, rotate it around a little bit. And I will go to the, for this user interface widget, you can move between different views, and then what we want to do really is move from the perspective view. If you hit the middle again, it will go to the ortho view, so you can see whether everything's lined up. This is pretty much the ground, that point there, where the first person player is standing. So we want the bottom of our model to be at the point of the bottom of the character, just along that line. I'm going to pull it across a little bit so that it's sort of in the middle, and then go back to click it again to go back into the perspective view. And let's see what it looks like through the through the camera. Doesn't look too bad. I'm going to maybe move it, oops, not them, move the model a little bit closer and maybe sort of rotate it around a little bit. Okay, so when it starts, this is going to be the view. Oops, that's moving the camera. You have to be careful what you're moving around. I have to reselect the model before I move it. Okay, so that's in the right location now. What I am going to do now that that's in the right location, we can preview what it's going to look like. If I hit play, at the moment I've got another thing running in the background, so it's trying to load another model. I can turn that off for a second. If I go to world and turn off load message, then that won't happen. Okay, so this is pretty much what it's going to look like when it loads. You're going to be looking in this direction and the model is going to load up there. If we wanted to do something like add lighting to it, we could, within the Creek object, we could come and say light, and we might want a point light. Let's put that here. One thing that's quite nice to do for giving a sense of depth to your model is, let me get the game view and just pull it over so that we can have a look. Okay, so that's just previewing what the main camera is seeing. So I can move this camera around. So we've created this light, we can move it around and it affects the model a little bit. So this is a point where you set up your site how you will want it in the viewer. I am going to be a little bit clever and I'm going to make this a blue light, not a particularly bright one. Okay, so here the range, you can see that the range, if I made it smaller, it wouldn't go so far. 10 seems to be fine here. Alright, so we have that light, and I'm going to paste another light and move that one sort of a little bit up and on the front there, and I'm going to make it a little bit more, bit of a warmer light and a little bit brighter as well. And I'm going to put that sort of up in there. Alright, so you get a little bit more of an interesting effect. You can play around, obviously, and move things around and see what sort of effect you want to get in the end. But I'm pretty happy with this like that. And you don't need to put this lighting in at all, to be honest. You can leave it out entirely. I'm just trying to make the scene to illustrate how you can sort of add elements to the scene that will also be viewed on your tablet device, or however you're loading up this content. Another thing that you can do is I might want to, for example, let's see, create a text object. Let's put the canvas here. I want the canvas to be in world space, and now let's sort of modify it. And I also want it to be sort of 0, 0, 0 to start off with. And the height, let's make it 20 by 20 for the moment. Maybe a bit bigger. Oh, no, not a bit bigger. maybe 2 by 2. What I'm doing here is I just want to make a little sort of information. You can put sort of arbitrary descriptive content in your environment. And I'm going to pull this. Anything that doesn't have scripts, basically. If you're just using standard components, you can put it underneath the Creek section, and then it will get shared. So I'm going to, my text is going to be Creek Reconstruction 2015. Okay. Let's see if we can get that to pop up. Never necessarily all that good at figuring out how to use these, but I'll give it a go. How's that? Ah, nuts. It's moved again. It's 2 by 2. That's a bit of a funny angle. That there. Okay, I think that was probably the problem. My size of my text was incorrect. So I can actually, I don't think I need to have that set. Or do I? 20. Where is my object? I'm sorry that it seems to be faffing around a little bit, but it's probably nice to go over the possibility of setting things up like this, because it's very powerful. You can put in arbitrary content into it and sort of get whatever you want out of it. So something's sort of coming in. It's a bit hard to tell what, to be honest. I think the text is really, really big. I think that's probably what's happening too. Yeah, the text is incredibly big. Let's just say stretch to fit, and yeah, I'm obviously not very good at setting these things up. 100, 10, say. All right, I'm going to keep it 2 by 2 and just make it really, really small here. And obviously this is not my forte, setting up textures, but that's all right. I think we can live with it. Okay. Ah, finally. Okay, this is pixel width, which is why it's acting like pretty nuts. So, great. Okey-doke, rotation. Something is the wrong way around. That one. Cool. Okay, so here is our content. It took a little bit of time to get it. I will do the process through again, just from scratch, which is hopefully not a bad idea. I hope I can figure it out. If you go to Creek, UI, let's add text, and pull that component up to Creek. Let's select world space, so it becomes a physical object that we can sort of move around. And let's make it 2 by 2. This is world size, I think, as we can see. Pull it over here, rotate it around a little bit to the point where you can see it. There you can see the text from this view. Let's move. I'm using WSAD keys to sort of move around, fly around, while holding the right mouse button to look around. So there's our text. We want it to say Creek Reconstruction 2015. And let's set, okay. So it's at 200 by 200. There it is, and let's scale it down. All right, actually, I think we can use the scale tool, which will make it a little bit easier to see what's going on. So I've just selected that scale tool, and now we can modify it here to the point where there it is in the world. You can see it showing up here. Select our text. Let's make it a bit easier to read. I'll make it really bright white, and let's see where it is relative to the player. Okay, so it's sort of like an information board at the start of your reconstruction. There you go, and a little bit down. Cool. All right, so we have this content here, and what I am going to do, actually, one thing that I've thought of, these sections we're going to have to just put in another place for the moment. Let's put it there. So, okay. Because the script is going to run through all of the sub-objects of this and try and apply a texture. So just make sure that at the moment only the box objects are in Creek, and we go back to our import set object properties, and what we're going to do is get it to make sure that root object is selected for Creek. We're going to set it up with the standard shader. The height map value is going to be the 0.005. All of these names are just for sort of advanced, if you want to change them. The format is JPEG. This is just saying how to map it. From one to the other, like what the name of the texture file to expect, and then to take those texture files and put them into these particular properties of the shader. So you don't need to change anything from these defaults. Just pull in the Creek object. The things that you might want to change are the max size, which is the resolution, and whether it's compressed or not. At the moment, for the sake of simplicity, I'm just going to leave the values as they're set. But you can experiment with having higher resolution. So obviously the highest resolution that you can have for the normal map and the height map is the 4096, which is the original file size. But I'm going to just downsample the height map and the normal map, because it tends to be, from what I've been looking at, the height map and the normal map doesn't have to be as high resolution to still look okay. Okay, so here we go. we're all ready to go. We have the root object selected. Now we hit Set Materials. What this is going to go through and do is for every object, it's going to look in the folder that the object is in, look for a texture file, which is the box001.jpg, apply that as the standard texture, look for a file which is box001_n, apply that as a bump map, and box001_heightmaps.jpg, and apply that as the height map. It's also going to go through and change the properties of all of those textures. So all of these were imported at 2048, and it's going to change the import properties to match this resolution and this setting. So these settings are either compressed, 16-bit color, or true color. I'm using compressed at the moment, which should be okay, but have an experiment and see what you think the final outcome looks like. This process will take a while, mainly because it takes a while to convert the image resolutions. It has to re-import that image at the higher resolution, which takes a little bit for each image, so it's going to take maybe another minute. Actually, it's done it. Well, that's good. Okay, so now it's applied the texture, automatically applied the texture to the model. We can have a look. It looks pretty good, actually. Pretty happy with that, especially considering that it's much, much lower poly count to the original. We can probably go through and see bits where it looks a bit weird. I mean, obviously this section is a little bit weird where there's a tree which has been, the image of the tree has been projected over this part of the model. This is actually sort of more of a problem with the PhotoScan texture projection, and there's ways of getting around that. You can remove cameras that you don't want to project and tweak it a little bit, but it looks pretty good. I think it looks pretty good. If we look into this is a sort of preview from the game. If we run it, then we can walk around. I haven't put in any objects that you sort of bump against, colliders. So you can just walk through these. You can walk right through the object at the moment. But the next thing that we'll do is add colliders. You don't need them. Obviously, it's not going to make or break the visualization if you don't have colliders, but we'll put them in. Okay, so there's a little bit of weird artifact here, which probably comes from the Boolean cutting out of this particular object, and I will probably go over fixing this in a later tutorial video, just because this is going really, really long now. For the moment, I'll just export it with this one, but it's not too hard to go through and just modify this section. If we look in our model view, if we click on it, you can see that the geometry from that section is a little bit funky, with these bits all throwing into that section, and that is because in the stage where it's cutting up the model for the low poly, it went a little bit funky. So we can fix that. I'm not going to fix it now, but look out for that sort of thing. And hopefully in another tutorial video I'll go through and just selectively fix that one. Okay, so there we go, we've got that. Let's just going to pull these sections. Now that we've finished texturing all of those sub objects, going to pull this back in. And where is it? Where is my text? Okay. So here's my text. If we preview it again, this is pretty much what it's going to look like. We arrive in our model and we have our arbitrary bit of text that we've stuck over the top of it. Creek Reconstruction 2015. That can say anything. You can have pictures in there if you want. And we walk around our environment. I do want to add colliders just to show you how to do it. It's really simple. We just come to our box and select the mesh itself and just say add component mesh collider, and we'll do that for all of these. In fact, I think I can do it all in one go. If I select all of them, add component mesh collider. Okay, now if we run it, you'll see that I actually sort of walk over the surface, and when I run into a wall, it will stop me from moving any further. So you can sort of get this idea of walking through it. Hopefully I don't get stuck in this hole. No, that seems to be working okay. That's good. There you go. Okay, so now you can sort of move across the landscape in kind of a reasonable way. Good. Alright, so we are ready, now that we've imported those sections, to export it. So if we go to Export, Prepare for Bundle Export. What we want to do now is, you'll see that all of the modifications that we've done to these objects, we've been moving them around sort of all in one go by modifying the location of the parent object, this creek object. But now what we want to do is convert the positions from being applied just on the parent object so that they show up on the individual object. So what we can do, just like the other one, we pull the creek, the parent object, into the root object input and hit propagate local positions. And what that does, I'm going to have to move the canvas a little bit, it's gone a bit funky, but all of the meshes have worked. What it's done is reset the position of the root node to 0, 0. This is all 0. Bam. And now that position information is in the individual section. So when we load that up, it'll load up in the right place. Do need to rotate this canvas. Not really sure why that happened, but it's not the end of the world. There we go. Okay, and now what we want to do is export to a bunch of different, for each different platform. So for iOS, you're putting it onto an iPad, or to Windows, or to a Mac, or onto an Android device. You need to select the different settings for it. So I'm going to go through and select for all of the different platforms. You go to Asset Bundles. Let's build for everything. Why not? It's going to take an awful long time to build for everything because it has to convert all of the objects into different formats. But that's fine. We'll get it out of the way, and then I will show you the last stage in the next video. So I'll just leave it processing and then show you what it comes up with in the next video. So we're all ready to go. We've selected all of the different platforms that we want to build this content for. And now all we need to do with the root node selected is hit Export Parts. And what this first does is go through and makes a prefab of all of those points that we've got in there. And now it wants us to tell it where to export these different bundles to, these different objects. So I'm going to go through and let's delete everything I've got there already. Just got this folder called bundle. I'm just going to select the folder bundle and hit OK. And if we go into that folder, let's desktop bundle, you see it's starting to export the PC versions of these. We'll just watch it for a second to see what it actually exports. Oops. Okay, so it's finished exporting the first box. I don't really know why it decided to minimize in that way. That's a bit funny. Oh, there we go, it's back. So it's going through fairly fast. You'll see these parts, so each box, each segment is a particular size that's a combination of the size of the geometry and the texture images. It's just going to go through and for every component that we have there, making an individual little chunk. And then when we run it, when we try and load it in the iPad device or whatever we're running it on, it will download a section at a time and then load that into the environment and then download the next bit and load that. So it sort of makes it updates as it's going, makes it run a little bit faster as well. So that's going, that's sort of happily working away to produce these. I will actually, I think it's going to be fast enough that I can show you. Actually, I'll do the last section in the last part of the video, just because this video has gone on for a fair amount of time. It's been an hour now, and you probably could use a break. So when we come back, the bundle folders will have been generated. There'll be content for all of the different platforms, for iOS, for Android, for Mac, for the web player, and for PC. And I'll show you what you do for the final stage.